In this video, I'm going to solve this question. Now, before you watch this video, make sure that you have gone through my previous video in which I was discussing the concept of permutations. So let's start with this question now. A college has 5 departments and each department has one representative, which we denote by A, B, C, D and E. From these 5 representatives, we have to select 2 representatives to attend a statewide convention. How many ways are there to select the 2 representatives? So once again, I'm going to show you different methods to solve this question. But before we start with the methods, first of all, let's find whether the ordering matters or not. So because we have to select 2 representatives, let us make 2 slots for 2 representatives. And now let's choose any possible outcome. So let's say one of the possible outcomes could be that the 2 representatives that are selected are B and D. So let's say this is B and this is D. So that means we have selected B and D. So this is one of the possible outcomes that we have, and I have chosen this outcome arbitrarily. Now if I change the order of this outcome, will I get different outcome? Let's see. So let me make 2 slots, and because I'm changing the order of the outcomes, so now I can write D here and B here. So this outcome now means that we have selected D and B. Now as you can see, these 2 outcomes are same. This is because according to the first outcome, we have selected B and D, and according to the second outcome, we have selected D and B. Note that in this question, we are not given that we have to select a principal or a secretary or whatever. All we are given is that we have to select 2 representatives out of 5 representatives. So if we select B and D, or if we select D and B, it's one and the same thing. Similarly, if I select A and C to be my 2 representatives, or I select C and A to be my 2 representatives, it is one and the same thing. So in this case, the ordering of the outcome does not matter. So ordering does not matter. Now let's proceed with our first method, which is based on pure logic. So method number 1, logic. Now see, we have to select 2 representatives out of 5 representatives. So let us make 2 slots here. In how many ways can we fill the first slot? Well, because any representative out of these 5 can take this place. So that means this slot can be filled in 5 ways. And for the sake of example, let's say that we have B here. Now having filled B in the first slot, in how many ways can we fill the second slot? Well, this is trivial. So we can fill the second slot in 4 ways. And for the sake of example, let's say that we have D here. And because we have to fill the first slot and the second slot, so we multiply these two, and this is equal to 20 ways. So is 20 ways the final answer? Well, no. This is because in this case, the ordering of the outcome does not matter. And when we say 20 ways, these 20 ways include all the outcomes such as B and D, D and B, A and B, or let's say B and A. So it includes all these types of outcomes, but we have seen that the ordering does not matter. So that means these 2 outcomes are not different. They are same. Similarly, in this question, these 2 outcomes are not different. They are same. Okay, so these are same outcomes. So that means if you write the answer as 20 ways, you will be counting every possible outcome twice. And it is twice because 2 representatives can be arranged in 2 factorial ways. So whatever 2 representatives you choose, let's say you choose A and E, you can arrange these 2 representatives in 2 factorial ways. And those 2 ways could be A and E and E and A. Okay, so that's why to correct for this thing, you have to divide 20 ways by 2 factorial. So your final answer would be, total ways would be equal to 20 divided by 2 factorial. Make sure you understand this concept really well. So what we saw in the beginning of the question is that the ordering of the outcome does not matter here. So if we write the answer as 20 ways, we will be counting each outcome 2 factorial times, because there are 2 factorial ways to arrange A and E. Now to correct for that, we divide 20 by 2 factorial. Now, before I proceed to the method number 2, I want to be super duper sure that you truly understand this logic method. So let me quickly take a small variation of this question that we have and let us solve that variation using the logic method. So let's say the variation that I am introducing is, so the entire question remains same. The only thing that I'm changing is that instead of 2 representatives out of 5, now we have to select 3 representatives out of 5. So let's solve this using the logic method that we have just learned. So because we have to select 3 representatives, so let us make 3 slots. And let's see in how many ways can we fill these 3 slots. So the first slot can be filled in 5 ways because any of the 5 representatives can take this position. Let's say the representative is A. The second slot can be filled in 4 ways. And the third slot can be filled in 3 ways. And let's say that the person who is taking the second slot is C and the third slot is taken by E. And because we have to fill the first slot and the second slot and the third slot, this is equal to 60 ways. But note that this is not the final answer because the ordering of the outcome does not matter in this case. So we have to do an extra step here. So let's choose one possible outcome. So let's say that the 3 representatives that we have selected are A, C and E. Now note that this possible outcome can be written in 3 factorial ways. So this possible outcome can be written in 3 factorial ways, and those ways could be A, C, E, A, E, C, E, C, A, C, E, A, and C, A, E, E, A, C. So this particular outcome can be written in all these ways, and these are in total 6 ways. So when we talk about 60 ways, these 60 ways include all these 6 ways as well. But as the ordering of the outcome does not matter, so we don't have to count these 6 outcomes as 6. We have to count these 6 outcomes as one outcome. So to find the right answer, you have to divide 60 by 6. Or in other words, you have to divide 60 by 3 factorial. This is because there are 3 factorial arrangements of a possible outcome. So the right answer is 60 divided by 3 factorial. So this is all about the logic method. I hope it is clear now. Let's quickly move to the method number 2, which is the direct formula method. The method number 2 that we have is the formula method, and I'm going to use this particular formula to solve this question. Now before I use this formula, make sure that you understand why am I using combinations here. I'm using combinations here because I told you in my previous lecture that whenever the ordering matters, we work with permutations, and whenever the ordering does not matter, we work with combinations. So in this case, the ordering of the outcome does not matter. So that means we are going to work with combinations. So the combinations formula that we are going to use is this particular one. So the number of combinations of n different things taken r at a time is given by NCR, and NCR is equal to n factorial divided by r factorial multiplied by n minus r factorial. So in this case, the n different things that we have are 5 different representatives. So that means n is equal to 5. And out of these 5 representatives, we have to select 2 representatives. So that means r is equal to 2. So we can directly use this formula now. So this will be 5c2, which is equal to 5 factorial divided by 2 factorial multiplied by 5 minus 2 factorial. So this will be equal to 5 factorial divided by 2 factorial, 3 factorial, and once you solve this, you will get 5 multiplied by 4 multiplied by 3 factorial divided by 2 multiplied by 1 multiplied by 3 factorial. This is equal to 20 divided by 2, and this is equal to 10 ways. So this is your method number 2, the direct formula approach. Now let's move to method number 3. In the method number 3, we are going to use the anagram technique to solve this question. So your method number 3 is anagrams. It's given in the question that we have 5 representatives A, B, C, D and E, and out of these 5 representatives, we have to select 2 representatives. So let's say that I'm selecting B, so S is for selected, and D. So I'm selecting these 2 representatives. That means A is not selected, so NS is for not selected. C is not selected and E is not selected. So these 2 are selected and these 3 are not selected. Now if you think of these as categories or let's say types, then that would mean that B and D are of one type, both of them are selected, and A, C, and E are of one type. These three are not selected. So that means according to this formula, we can write that P is equal to 2. So 2 of them are of one type, and Q is equal to 3 because 3 of them are of second type. And we don't have any third type, so we can skip R. So now according to this formula, the answer is 5 factorial because n is equal to 5 divided by 2 factorial, 3 factorial. And once you solve this, you'll be able to see that this is also equal to 10 ways. So this is all about the different methods that we have to solve this particular type of question. Note that you can use any method you feel comfortable with. I wanted to show you all these methods just to make sure that you develop a very good basic understanding of permutations and combinations. So this is all for this lecture.